know why wearing a white shirt makes you feel cooler than wearing a black shirt?
Or maybe being inside a black car, feeling hot on a warm summer's day.
Why is this? This is because absorption of heat differs between separate materials, and colours absorb light differently to each other.
Today, our experiment will answer the question, do dark colours absorb more heat energy than light colours?
Heat and light are both different types of energy. Light energy can be converted into heat energy.
The difference between the colours is that they are all different wavelengths in the electromagnetic spectrum. An example of this would be that a black object absorbs all wavelengths of light and converts them into heat, so that the object becomes warm. A white object reflects all wavelengths of light, so that light is not converted into heat and the temperature of the object does not increase dramatically. I'm wearing a black jacket at the moment, and it's pretty hot, so our hypothesis is that black objects will absorb more heat than lighter objects. One of the biggest priorities we have in this experiment is to make it as safe as possible for everybody involved. We wouldn't want anybody to get hurt. For this reason, we have developed a diverse safety program and risk assessment, so we are safe as harm at all times.
Before we began the experiment, we needed to identify the variables. The independent being the colour of each piece of cloth, the dependent being the amount of heat absorbed by the coloured cloths, and the controlled being how long each piece of cloth is in the sun, the location of each piece of cloth, the light intensity of the sun on each cloth, the surface the pieces of cloth are placed on, the material of each piece of cloth, and the measuring instrument. First, we gathered our materials and found an appropriate place to conduct the experiment, which is in reach of direct sunlight. We then laid the cardboard down and sticky taped each piece of cloth onto the cardboard so the wind didn't blow it off. We recorded the temperature of the cloth at 0 minutes, started a stopwatch, and remeasured the temperatures in two 10-minute intervals, then laid the cloths down in the shade for 5 minutes to cool down before repeating the experiment again.
In conclusion, we can see that our hypothesis that darker colours absorb more heat than lighter colours was correct. The colours that absorb the most heat in descending order was black, dark green, blue, red, purple, yellow, orange, and lastly white.
Our results and the overall changes in temperature are shown here in these fancy graphs.
For reliability, we only got to perform the experiment twice, but we believe the results are quite conclusive and will lead in the same direction if we perform it the third time.
We found that the weather also played an important role in our findings, as the temperature the cloths were at were developed in irregular patterns because of the clouds blocking the sunlight.
We would have liked to test it on a clear sunny day where there was no external stimuli impacting on our results. Sharing an infrared thermometer gun between 3 groups impacted the recording of our results. Having one gun individually is optimal. Even though we expected to have the same material for each cloth, they were all slightly different in both size and fabric. Getting the same packet of multicolored cloth would ensure the same size and fabric was adhered to.
For further study, we can research the effect of the weather on the heat absorption of the cloth.